presented in this session. Before I'm going to get start my session, I would like to thank the Kungunadu Engineering College Management and Organizing Committee of this Atal FTP program, giving this great opportunity to share this knowledge about precision healthcare through AI and deep learning aspect. By the way, okay, my discussion is going like this. First of all, we are going to discuss about what is artificial intelligence. Then slowly we are going to down to the deep learning, brief about deep learning. Then we'll go for the comparison between deep learning as well as machine learning, and followed by architecture of deep learning, and then how this deep learning aspects and AI combined together is applicable in this healthcare area and its various research challenges too. Finally, I'll come up with the references too. This is the way I'm going to discuss about the topic, whatever mentioned in the earlier slide. First of all, I'll start from artificial intelligence. Even yesterday, a speaker might have given some basics about artificial intelligence. Anyway, I'm not going to bore you. If you feel that anything, okay, let me know. You can interact. Actually, this is a textbook definition of artificial intelligence by Stuart Russell and Peter Norvig. Actually, the artificial intelligence is a branch of computer science aim on building machines and software with intelligence similar to us, that means a human being, so they can perform thinking, reasoning, decision making, problem solving, and understanding natural languages like human. This is a formal definition of AI. Sir, is there any informal definition for the AI? It will be very much easy way to understand. It's there. That is machines with mind. Machines with mind. That is an informal definition of AI. That means how that is will come up with machines in intelligent aspects like the human being. For that, just we are just dealing about artificial intelligence. Straight away, we'll go for that evolution of artificial intelligence during 1950s. This word artificial intelligence is that is was coined by doctor and scientist John McCarthy, and thereafter it has spread and then that is grown in a different way, and it has come up with different varieties and different programming languages, Prolog, and various aspects of GPS, etc. Then during 1980s, the machine learning is come into the picture. Actually, the machine learning is a subset of artificial intelligence. The machine learning begins to, that is, flourish the that is the aid of machines. That is, sir, what is the difference between the machine learning and artificial intelligence? Already mentioned what is meant by artificial intelligence formally and informally. Even in machine learning, it's an actually that it's an idea or it's a subset of artificial intelligence to process and will come up with decision making and generic. That is, you can refer the textbook definition. In informal definition of machine learning is it's an one of the tool, mathematical tool to analyze and process the data and come up with the conclusion. That is then main aspect of machine learning. Then you see here the deep learning. Deep learning is the subset of both artificial intelligence and machine learning. It kickstarts during 2000 10. That is an so 1.5 decades back. The deep learning breakthroughs drives of AI booms is what I want to convey. The keyword is represent the number of hidden layers in that particular neural network architecture. The deep learning is is the future of artificial intelligence. Even we people are realizing partially about that beta versions and about Chat GPT, Gemini, Google Gemini, and etc. So these are all the examples under deep learning aspects. Even most of the faculty members and research scholars approach various deep learning models to CNN. That means CNN, RNN, LSTM, and even the generative AI models such as large language models, LLMs, transformers, autoencoders, etc. There are a lot of aspects are coming to the picture. And these are all the major areas of artificial intelligence because it's an core aspect. So that I'm focusing a little bit more on this area, and thereafter will migrate to deep learning straight away without discussing the machine learning. And parallelly, I'm going to cover it the deep learning aspects too. Just a minute. Going to switch off camera. Then see here, these are all the dependencies of AI. Such actually here in artificial intelligence, such is playing major role to finding the solution to the particular problem. There are three types of searchings are involved in this artificial intelligence, namely uninformed search or blind search, informed search or heuristic search, adversarial search or game playing search. There are varieties of searches which is okay. I'm fall under this particular topic. So which has come up with uh, solutions to that particular problem. So among that, it will identify the optimal one. Then, sir, what is the need of logic? There are variety of logics are discussed under AI, such as proportional logic, first order predicate logic, ontological representations are used here to representing the knowledge. So it is similar to the brain aspects. That means how the human brain is recording, that means are capturing the knowledge. Similarly, the computer system has to come up with its knowledge representation with these technologies. That means whatever I mentioned, just know that is proportional logic, first order, predicate logic, ontologies, everything. Then the middle layer, machine learning, there are three major types of learning techniques: supervised, unsupervised, reinforcement learning. All are just fall under these three major categories. There are so many varieties. Supervised, you know very well of the supervised learning. It is like an classroom environment. The teacher, whatever it is going to thought, that is going to be learned by the students, and they are applying and following the same. And then unsupervised learning through distance mode. Uh, that is, the students are going to learning themselves. Then the reinforcement learning is a kind of semi-supervised learning too, and it will having a major two aspects: planning and rewards. I don't want to go for in depth of that. So anyway, the machine learning aspects are to aiding the devices or electronic gadgets to make smart decisions. Planning, it's a sequence of actions. There is a difference between planning and scheduling. Scheduling is planning with the time. That is called it as scheduling. Planning is again sequence of action that leads from initial to goal state. Then the bottommost layers are major applications of this AI domain, that is NLP, natural language processing, vision, computer vision, robotics, followed by expert systems. Then the next will go for three major categorization of artificial intelligence, such as narrow, otherwise also call it as weak, general intelligence or strong, super intelligence, or otherwise also known as hypothetical intelligence. Narrow, otherwise also call it as I mentioned, here it is weak. That means the particular types of AI agents or machines are able to perform well-defined tasks. For example, the coffee maker always going to prefer a coffee. That's it. It doesn't have any sense to come up with cooking of vegetable biryani or sambar, dal sambar, whatever it is. The second one, general intelligence or strong intelligence, that kind of devices or agents able to perform the additional or the requested task as per its past experience. For example, that machine has the experience of how to ride a bicycle, but the machine is forced to ride a bike, then it will ready to do. And the third one, super intelligence or hypothetical agent, is an that is mesmerizing device. Whatever we have seen in our that is Hollywood movies, that robot, or the Rajinikanth acted movie Endiran 2. That is Endiran and Endiran 2.0, and North Indian. Okay, that is in North India it is Ravan. It is an Shah Rukh Khan acted movie. That kind of humanoid robots are fall under this kind of category, super intelligence. It will take hardly another 2 or 3 decades to reach us. These are all the three major categorizations, and these are all the components of artificial intelligence. The artificial intelligence is not an easy science to describe, but it's an fuzzy border. That means a vague borders which are connecting. Look at here, mathematics are why we need for mathematics. Actually, the mathematics is an one of the important role-playing aspect in this artificial intelligence. Even whatever the topics which I mentioned, machine learning, deep learning, even generative AIs, everything is purely based upon mathematics, along with biology and science. Without this, there is no these are all the technologies. So mathematics are mainly used to represent the models. How do we come up with the models? So can you tell us some mathematics in this regards? For this, for learning AI, ML, deep learning aspects, you should have need about probability, statistics, linear algebra, then other the Gaussian fuzzy pairs, Gaussian models, or something. Even other aspects too. That means based upon the environment and the problem solving nature, we can choose our mathematical models. Then computer science, in order to come up with the specific idea to algorithm programs and related hardwares to execution of the same. Philosophy, how do we come up with the justification, and that is we are giving our explanations. Psychology, that is human behavior, or how do we interact with other humans and everything. Statistics already mentioned. Physics, it's an one of the aspect which I mentioned. It's in the science. Biology and other disciplines, how our body is working, what way our brain is interacting with other correct organ systems and everything. This is a short summary of the fields of artificial intelligence. Most of the things actually I mentioned earlier. You look at here, knowledge representation, planning, computer vision, reasoning, problem solving, motion and manipulation, natural language processing, social intelligence. Among that, machine learning already we have discussed. Supervised, unsupervised, reinforcement. Again, how these learning techniques are broadly classified. See here, supervised decision tree, association rule mining, inductive logic, support vector machine. There are so many varieties. Similarly, unsupervised learning, clustering, similarity, and metric learning, sparse, dictionary learning, genetic algorithms, Bayesian here, reinforcement learning, neural networks, deep learning, manifold learning, everything. Then see here, the artificial intelligence, any system that exhibits behavior that could be interpreted as an human intelligence. You know about that picture, whatever I kept it here, Sophia. Um, there are so many um, robots are exist, but there isn't some speciality in this robot. One of the first robot who got citizenship in Saudi Arabia, UAE, and also it's an humanoid. That means it can understand our feelings, sense, right? Even I have a video clip too possible. I can play the video how that how this robot various devices and its functionalities. The person whether this passes thrice person. I know.
Hi, Paul. How are you today?
Fine, thanks.
Also,
Are you ready to do some work this morning?
Sure.
Recognition
You say you love
NLP.
me. You say you love me. You say you love me.
So it's a choreography program, okay? Software for walking style and other things. The Wi-Fi, infrared, Ethernet, everything. Object detection, okay? Whole body motion to capturing the object.
You say you love me. You say
Catch
you
it.
love me.
Command catch it.
You say you love me. You're easy, my friend.
Come here.
Listening sound completely. Where the sound is being accordingly adjust and you can do it for these walk.
You say you love me. You say you love me. You say you love me.
Try again.
That's not really funny. You say you love me. You say you love me.
Yeah, I'm impressed.
It didn't hurt. You say you say you say you say you.
So this is an a simple video clip about how the robots are accepting our commands and proceeding. Okay, it's a task. So, then, okay, everything is controlled by computers. Even about pattern matching. Google can decide what website you watch. Similarly, the YouTube can decide which kind of videos you can watch. That means they are actually narrow downing our searching and seeking aspects in the internet, right? Somebody done this um, annotation. Okay, I do one thing. Sorry for the interrupt. How do I remove this annotation? Somebody done annotation here. I have not done. Is it okay? Are you looking this annotation lines? Okay, right. So the mobile can uh, decide to change your contact number in future. Okay, that information. Okay, what kind of information would like to delete? And Amazon. Okay, you know about Amazon. Okay, Alexa kind of things. See here, this is a tree representation of AI, disciplines and its applications. Here, the branches are represent the major applications of this artificial intelligence. That the trees are represent that is branch. It's representing applications, and the roots are representing the various aspects which you already discussed under the components of AI. Okay, the straight away will go for deep learning. Already, I connected the link among these various aspects: AI, machine learning, and deep learning. Actually, the deep learning is a branch of both AI and machine learning, which is completely based on artificial neural network (ANN). The neural network is going to mimic the human brain, so the deep learning is also a kind of mimic of human brain. Already mentioned. What that the deep word is deep, which is represent where the deep represent the number of hidden layers which is present on that particular uh, deep learning model. This is what mentioned here. So the deep learning is that the deep represent the number of neurons among the layers too. See here also you can call it as deep neural learning or deep neural networks. This is an that functional representation of deep learning, how derived from the artificial intelligence and machine learning, and then followed by deep learning. So actually, subset of machine learning make the computation of multi-layer neural network feasibility. You look at this how the human brain, the basic units of human brain. It's a neuron. The neurons are artificially mimicked. This is an artificial neuron. See here what are the major components: nucleus, dendrites, soma, cell body, axons, and connecting with the other neurons. Similarly, see here the set of see here neurons which are connected and with another neuron, and it is going to interact with the other neurons further. So each and every neuron has its weight function. Biologically speaking, we people are using salt. That means NaCl, sodium chloride. So but it's more, and it is going to give an more connectivity and the sense that is called as weight. It is going to take about that particular cell or that neurons input. If it is the weight, that signal is greater than or equal to some functionalities are given. So accordingly, it is going to fire. See here how the human brains are mimicked. Actually, our brain has an important component that is called it as auditory cortex, which is going to merge both our visual information as well as our hearing information too. Sir, what about the physically? That means the blind people or the deaf people. So that case, it is going to recognize from any one particular sensor. It seems either through the ear and it is, or either from the eye. If both are it is working fine, then it is going to merge together and it will come up with the right decisions and learning based upon the auditory cortex representation. See here how that is the blind people can walk. You know how the bats are dealing. The similar way it is dealing. See the difference between the machine learning and deep learning. The first field, that is the first column, is completely deal about machine learning. Actually, the machine learning is works on small amount of data set or the accuracy, but the deep learning works on large amount of data, because nowadays there are a lot of sensors and every smartphones are connected with the internet. So it is generating big data, so no problem in that case. And it is in machine learning, it depends on low end machines. Even we can run those machine learning models in our low configured laptops and desktop too. But deep learning aspects, we need an heavily dependent high end machines like high performance computing, GPUs, Google Colab kind of environment. And also in machine learning, it divides the task into subtasks, solve them individually, that is locally, and finally combine the results together. But here in deep learning, solve the problem end to end. The whole problem is going to be processed in parallel manner. And then here it takes less time to train, the reason behind this, because it has small amount of data. Here it takes longer time to train, but the testing time may increase depends upon the data and the number of parameters, that means features, etc. But here the less time to test the data once the models are get trained. Look at here how the machine learning aspects are identifying the detecting that object. We are explicitly processing the features. What are the features? Car means it's four wheel. Even the heavy vehicles also having four wheels, and that width and length of the vehicle and the front mirror, front rear lamp, that is front lamp, everything, tail lamp, everything is going to structure, height, everything is going to be considered. But here in deep learning, we are not going to explicitly passing the features of that particular image. Image is going to be entirely processed, so that it is going to consider the three levels: the low level, medium level, high level. The low level completely pixel values, dark and that is bright pixels. Thereafter, and the middle level, that is medium level features based upon the that is that is region based, and even that is what is that size of the tail lamp regions where it is that headlamp, and what is the size of that indicator, and mirrors, side mirrors, then wheelbase, everything is going to be processed. Then that final, okay, that high end is going to be in mirror size and width of the vehicle, height of the vehicle, length, everything is going to be considered. This is the way the deep learning models are going to process and come up with the conclusion. This screenshot, that is image, is going to cover the difference between machine learning and then deep learning too. So I don't want to discuss about this. Straight away we'll go for inside that deep neural network. Actually, the deep neural network combines multiple non-linear processing layers. Actually, it's a simple elements operating in parallel and inspired by biological nerve system. Actually, it consists of three major layers, such as input layer, output layer. In between the input and output layer, there is an enormous, there is a number of hidden layers. Actually, the layers are interconnected via nodes, that is call it as neurons, and each hidden layer using the output of the previous layer. So that is the number of hidden layer calculations, or it is completely black box. How many number of neurons we have to keep, how many number of hidden layers we have to keep in between the input and output layer. It is very difficult, but we can decide the number of input layers. That is how many number of features are we going to process. Based upon that, we can keep the number of input layers. Similarly, the number of output layers, that is depends upon the number of outputs. Suppose it's a binary class, yes or no, 1 or 0. In that case, we can keep 2 output. Okay. So next, straight I will go for how the deep neural networks are learning. Look at this. There are that is various components of this neural network aspects. It's an input image. There are a variety of convolutional layer and ReLU, that is rectified linear units. There are variety of rectified linear units. Then pooling, layer, pooling max layer, and then followed by one more, the decision making layer will come into the picture. That is an output layer too. See here, this is an image where the image contains one of four different categories of the object, and we want to the deep learning network to automatically recognize what kind of object it is. Either it's a flower, or what kind of object, it's a vehicle, anything. So using that training data, whatever we train. So see here, whatever I mentioned, it is going to process that data, input data in that three aspects: low level, medium level, high level. So each and every layer in the network takes the data from the previous layer, whatever I mentioned in the earlier. It is going to take it, transform it and process to the next layer, and the network increases the complexity and the details of what it is learning from the layer to layer. So initially it is going to learn pixel wise, thereafter region boundary wise, then colors, everything. Finally it will conclude it's a flower. So this is a way which is learning. Already mentioned. Suppose it's a face recognition system which is dealing about deep neural networks. Look at here how the face recognition is processed. The raw input is processed in a low level. See here where the high resolution pixels and the dark low resolution pixels are going to be processed separately. Then middle level features, see here regions. I mentioned about eyebrows, and then our eyes, nose, our mouth, then chin, everything is going to be processed separately based upon the regions. And the high level, see here our face gesture, shape, structure, everything is going to be processed. See here. So the number of layers which is dealing about all this, and it will come up with the conclusion. See here the learning algorithms of how much see here 30 exaflops. That is, we are still dealing about TB, terabytes. Thereafter, exa, feta, and then followed by exa, that is exaflop and everything. 30 GPUs per day, which is processing this information. This is a traditional and deep learning networks here. That simple neural network has only input layer, one single or a few hidden layer and followed by output layer. But the deep learning neural network has multiple number of hidden layers. Okay, so, sir, how do we fix this number of hidden layers? Only option is we can come up with the trial and error basis. According to our result aspect, we can increase or decrease the number of hidden layers as an only possibility. That's what these kind of technologies are called as black box based aspect technology, because we doesn't know about that internally how far it is happening. There is no specific standards for fixing the number of hidden layers and number of neurons, everything. Only trial and error basis we can, like our TV remote. We doesn't know what technology it is. While you are pressing the button, power button, TV is going to switch on, right? So similarly, we people are using this uh, technology, that is deep learning aspects. See here how it is dealing convolutional. There are variety of deep learning aspects: CNN, RNN, LSTM, and so on. The CNN is convolutional neural network exploits spatially local correlation by enforcing local connectivity patterns between the neurons of adjacent layers. Actually, the CNN is helpful or applicable on the text and numerical data kind of things. Then, see here, CNN is inspired by visual cortex and also it's in deep nets that are used for image, object, even speech recognition too. So it is pioneered by Jan Leeken. Deep supervised neural networks are generally too difficult to train. Actually, the CNNs have multiple types of layers. The first, of which is convolutional layer. Look at here, the convolutional layer and everything. How far, which is dealing. Already, I told you, each neuron has its some weight. So even that fixing of weight also going to be assigned or fixed according to the input or environment. Randomly it is going to be fixed, but after that the weights are going to be fine tuned as per the uh, output of the particular layer. So you see here, a series of filters forms layer. Look at here, there are three types of colors here: red, blue, green. So the reds are on particular filter layer. Then blue neurons are going to be formed in another layer. Green is another layer. So the layers are going to be formed in such a way, and it is connecting with each other and dealing all computation aspects. See here how the convolutional layer is working. Already I mentioned weight and input layers, then convolutional layer, pooling layer, fully connected, and softmax layer. So this convolutional layers are going to process the weight and inputs with that K future maps. Then the pooling layer is going to get trained. That is all are it is fully connected with the you see number of fully connected, that is pooling layers are fully connected. That means each and every neuron from that particular layer is going to be connected with all other neurons which is existing in the adjacent or the next layer. That is called it as fully connected layer. So all are which is gathered together as an hidden form. Then finally, the softmax layer is going to mapping that result with a particular specific class. Actually, this CNN convolutional neural networks are multi-layered, already mentioned. So that is an convolutional layer responsible for filtering the input image and extracting the specific features such as edges, curves, colors, everything. Then pooling layers, here it is there, pooling layer. The convolutional layer already mentioned, it is doing always filtering mechanism. Then the pooling layers improve the detection of unusually placed objects. For example, here face. There is an after detecting this, that is processing this image, it will come up with the conclusion of whether this image is male or female. That is an categorization, so that it will identify studs, long hair, everything, whatever it is given. So normalization layers improve the network performance by normalizing the inputs of the previous layer. That is the purpose of normalization layer. The last one, it is fully connected and then softmax. These layers are okay. Neurons have full connections to all activations in the previous layer, similar to the regular neural networks, so that it will come up with the final conclusion of what image it is. Like that. Look at this. How the layers are connecting with others and finally come up with the classifications here. Input layer, convolutional and ReLU, rectified linear unit, pooling, then convolutional again. Okay, that number of layers are repeated here. Then you see the classification of the softmax layer fully connected with all together. Then see that softmax layer is holding all class labels. With that, which one is maximum, which is going to be calculated. With that, which is going to come up with that results. Next, we'll go for RNN. Already mentioned where we have to apply CNN, images, text, even speech, content, and everything. RNN stands for recurrent neural network. Actually, see this, which is developed by brainchild of see this Jurgen and Seb, right? Et al. And see here, RNNs have a feedback loop where the nets out is fed back to the net, along with the next input. That means feedback based neural network, and also which is useful whenever the data is in a time series based. For example, every minute data is going to be taken, particularly the climate prediction and all. We cannot expect the same data on the every time series, that is time interval. In that case, that recurrent neural networks are applicable. So the variants of recurrent neural network is LSTM, long-term short memory, LSTM, long-term short memory, LSTM, long short-term memory otherwise. So this, look at this long short-term memory. You might have heard about circuits, the COA or digital systems. That means the two variety of circuits, sequential and combination circuit. The circuit with memory. So you see here, LSTM can learn very deep learning. The task requires memories of events that happened thousands or even millions of discrete time steps ago. So which is memory cells that is hold the previously that the past information about that particular aspects. Right. These are the very popular CNN models during this particular year. LeanNet, AlexNet, PGG, even ResNet, YOLO, various aspects. These are all the various pre-trained models too, regarding whatever which is mentioned in this slide. See this AlexNet, GoogleNet, ResNet, VGGNet, Inception V3, and its corresponding models. How many max pool layers, convolutional layers, and exactly which is existing in this in between input and an output layer. Then this is a computational complexity. We need already it's an high performance computing devices like a GPU, graphics processing unit, and we see that comparing complexity of AlexNet, Inception, whatever you see here, how much that informations are taken, and other aspects too. Memory. These are all the working procedure of deep learning. That is, understand the problem and check feasibility for deep learning. Already mentioned when we have to go for deep learning. If the data set is too big and we have enough computing resources, that means high-end resources, we are expecting accuracy on more and quick fast computing in the result, decision making, then we have to go for deep learning and identifies the relevant data and prepare the data accordingly. Then they choose the deep learning algorithm whichever is suitable or applicable or according to your data set, training the algorithm and test the model and fine tune the performance. Look at this, the diagrammatical representation of that deep learning model development cycle. See here, the data scientist who gathering the data and they come up with that data and model. Then the model is get trained and it's going to be applied on the real-time environment. And based upon that feedback, it is going to be fine-tuned. Then finally, it will come up with the classification, detection, segmentation, everything from the real-time environment. Okay, even you might have seen nowadays, most of the signals are applied speed detection devices. once if you are passing to the cross, that is passing to the signal, that there is a display which is showing your speed. So that is completely based upon this deep learning models and the other aspects. These are all the advantages of deep learning. Best in class performance on problems, reduces a need for future engineering, eliminates unnecessary cost, identifies defects easily that are difficult to detect, and these are all the advantages. Disadvantages: large amount of data is required, computationally expensive to train. Obviously, the number of epochs are more, and no strong theoretical foundations. Requires a good understanding of how to model the multiple modalities. Multiple modality means that is if we are going to process text, video, audio, graphics, everything all together, that is called it as multiple modalities. Okay, so these are all the research and application aspects of deep learning. Mainly medical research, precision agriculture. This is what I'm doing currently using uh, these aspects through with my scholars. Then bioinformatics, educational research and application, psychological research, neurological research, then therapeutic applications and everything. So mainly we are going to discuss about medical research. See here, deep learning applications under medical we are going to. Actually, the artificial intelligence and medicines and it's a part. See here, the virtual branches. That means even we no need of that is required physical presence of doctor. That means expert systems. There are three types of machine learning algorithms which are already mentioned. Anything we can apply while we are developing such kind of expert systems according to the applications. Mainly supervised and super. These three algorithms playing vital role. See here that machine learning, that is also called as deep learning, mathematical algorithms that improves the learning through experience. See here how even nowadays we don't need to wait for 24 hours to come up with our reports while we are going for diagnosis. Straight away we are dealing about smart devices for measuring our pulse, heart rate, heartbeat, even our sugar rate, um, blood pressure, everything, right? How those components are developed with these technologies, right? This is what we are going to discuss further. So what makes that healthcare different? See that so often see here often very little labeled data, that for example clinical natural language processing. The doctors are using that mainly English here, but most of them are something natural language processing, motivate semi supervised learning algorithms. Then sometimes small number of samples, that means that may be in rare diseases, so it has only a limited amount of data. Even see the model the problem it's carefully for such cases, because we don't have get that much of data, it will be very difficult to train the models too. Then lots of missing data, varying time intervals, and censored labels and everything. Even difficulty of identifying the data, need for data sharing agreements, and particularly even my scholars are facing lot of issues for getting ethical clearance to access and that is process the patient data. So that we are using some simulation, that means models, even generative AI models to come up with the data based upon some sample records. So difficulty of deploying the machine learnings if the data is very less. It's a large data set. Obviously, we'll go for deep learning aspects. And you see this, even that is in a survey, President Obama's initiative to create an 1 million person research cohort, the core data set, baseline health exam informations. Um, Even you see this diversity of digital health data set. How do we label the there is a lab tests, social media informations, imaging, videos, and see this genomic and everything. And industry interest in AI and ML healthcare, it is booming up, and they are come up with a lot of new ideas, innovatives, particularly in I don't know how many of you are aware of it. Google Lens, I don't know how many of you heard and aware of it. The Google Lens gathered all our that is retina scan. They are tie up with our Shankara and other eye care Agarwals, the other eye care hospitals. They are scanning globally, and based upon that, the Google Lens is going to get trained, and it will come up with disease predictions or what is our body conditions in future. Similarly, IBM, and there are so many that international that is corporates are involved in this, that is healthcare aspects. Particularly, you see this in this situations, emergency cases due to limited resources. During the pandemic, the people are suffered to get the bed and even oxygen, those kind of things. So that they are incorporate artificial intelligence and machine learning in this healthcare. Particularly data in emergency departments, they must have required all this data in available form or processing, right? So generic flow diagram, how the healthcare sector is dealing about this data collection, mainly hospital data, the electronic medical records from the laboratories, cloud data sharing, and it is going to be processed, data pre-processing and model selection through the natural language processing and even machine learning or deep learning aspects. Then the model is going to be trained. See here, either actually here mentioned, one decision tree, all are machine learning aspects. The last one, deep learning. Even nowadays, most of the applications where incorporates deep learning models. That means generative AIs, even explainable AIs and everything. These are all the generic flow diagrams how the deep learning models are dealing, this healthcare aspects. See here one after another. So first you go for improve accuracy of diagnosis, prognosis, and even risk prediction and everything. So actually it is going to dealing about all this based upon the data, how far it is going to be. See, improve the accuracy. See here, that risk prediction and visualization is maximum, which is dealing about this. See what are all the disease it is going to be. For example, the symptoms of corona. There's saliva, breathing issue, even cough, sneezing, kind of things. It may be a symptom for a normal fever too. So we have to be very keen on this, predicting what kind of disease it is. So predictive hierarchical clustering, mechanisms we can apply. Even hierarchical clustering of things. So many aspects we can do. Next one, optimize the hospital process, such as resource allocation and the patient flow, everything. So for this, what is that number of beds availability and what kind of disease it is going to be, prediction of futures, how that disease is going to get affect, even that variations are formed in corona, that is in the virus, and the wave 1, wave 2, we are facing a lot of issues, right? So next, see this, how this automate detection of relevant findings and everything. See here, how the cancer cells are going to detected, automate detection of relevant findings in pathology, radiology, that means skin based diseases, everything. You see this, the classification of some diabetic aspects. See here, which is going to process our eye retina, and it will come up with uh, where this conclusion of, is it normal, mild, or moderate, severe kind of things. It's an decision. See here, normal, mild, moderate, or severe, based upon our data collection. So only that is going to process retinopathy from the retinal fundus images, and it will come up with the conclusions. See how that particular system is working. Input and background, segmentation, everything already whatever I mentioned. Feature extraction, if it is some machine learning, features are going to be extracted explicitly. Then otherwise, if it's a deep learning, then it will go for that is indirect representation of the features. Normal is here, abnormal, then it is what is the mild, moderate, or severe, it is going to be classified. Then the detection also is available when the key patterns of interest are discovered by the integrating information across many patients. These are all the key advances. One, that is very efficient, accurate search over sub areas of image. Then second one, use hierarchy to search multiple resolution. Okay, right? And then next, discover new medical knowledge, that is clinical guidance, best practices, and everything. So for that, see how do we'll come up with best practices and everything. Next, identifying the patients, subgroups, and which category of that disease it is. Everything is going to be considered. See, diagnostic decision support system, identifying the patient subgroup. Suppose that diabetic is come into the picture, then automatically it will damage all the organs of human body. Slowly it is going to get affect our digestion system, that is even mainly our kidney and everything. So then it is going to identify groups where it is going to be. Then there is an enabled connected health informatics, which is dealing about here heterogeneous hardware components, GPUs, field programmable gate arrays, and other aspects, which is dealing about automation, accuracy, and consistency with this artificial intelligence and the radiology. You know about it's an one of the important field in the medical domain to dealing about cancers. Okay, right? So see here how far it is. Automatic detection and measurement of image featuring in bio markers, the analysis of coronary and peripheral vessels and everything, and even integration of X collaboration detection and quantification. See here pathology, skin, and other things. Even I've already mentioned that how the radiology is very much helpful. Even it is healing the tumors, brain tumors, and even breast cancers, everything. So for that, we are going to apply, what is that impact while we are going to misusing this, or the normal cells will get affected by this radiology chemotherapy. So that is the hair loss and some various side effects. In order to overcome that, we are going to use artificial intelligence for radiology for dealing all this kind of tumors and everything. Even medical imaging, see here, non invasive visualization of internal organs, where it is that CT scan, ultrasound images, MRI images, everything going to be see here EEG, ERG, UOG, ENG, EGG, everything is going to be signals, biosignals, which is dealing a kind of signals, that is our heart signals, even brain signals, everything. So look at here, the use case which is dealing about the ultrasound image of that particular problem. Right, see here the tumor tissue characterization using ultrasound, how that image is going to be processed, and it will come up with that decision making using deep learning model. See here, so which is going to see use of robots to deliver treatment and robotic surgery, everything. Even already mentioned, in future we don't need to expect the surgeons to physically appear. Instead of that AI trained deep learning models are going to guide the doctors to do the surgery. Even use of robots to monitor the effectiveness of the treatments and everything. Passion, you see this care robot. See here in between this. The remote care human actors. It is interacting the human, and it will gather the information. And the success, you see this mammographic mass classification, brain, lesions, airway leakage. These are the various aspects. The technologies are incorporated, and it is dealing. Even one of my research scholar who is dealing about Down syndrome prediction using deep learning models. Actually, I thought of to discuss, but those works are communicated recently, so waiting for publication, so that I'm not in a position to discuss those ideas, but I can orally convey earlier Down syndrome predictions. You know what is mean by Down syndrome? That means if the fetus is formed in that is mother's that is uterus, then the placenta, how far it is going to get affected or lengthy. So based upon that, if that placenta will be okay, right, fell down, okay, or more long, then there is an issue. So that, okay, that is called as Down syndrome. That is going to be predicted. So what will happen in that case, that a baby is okay, behaving like an immature, and is not in a position to stably, okay, stand and deliver, and okay, their hands and legs are going to be shaky, heads also going to shaky, not able to speak properly. So these are all the various issues. So we are predicting earlier that kind of diseases. And even another scholar is dealing the same deep learning models in the precision agriculture domain too. Uh, so these are all the various success under this. And these are all the medical imaging open data sets. Already the Kaggle providing a lot of open data sets, lung cancer, skin cancer, even breast cancer too. Even that whatever I mentioned earlier, Down syndrome aspects. Even my scholar gathered from the hospitals in CMC, SRM. So thereafter we fine-tuned our models, everything. You can see skincare data set, and then other medical image analysis aspects are given. Please, you have to note down, and you can use it for your research purpose. Even you can apply the existing models. Before that, you should know the fundamentals of that is deep learning, machine learning, and artificial intelligence concern. Where we are going to, that is, you are going to apply, and what kind of result are you going to expect. Everything is very much important. These are all the other resources, just very much helpful to you people to practice these kind of platforms. That is CR unit, DL, medical imaging, survey, TensorFlow, okay, and then deep learning, okay, see deep compression papers, even CR, Google Colab, etc., Keras, everything. Right? And additionally, the data science is an recently, okay, just that is one of the hot keyword that people are very much okay preferred in this. The data science, okay, look at here how that the data sciences form. It's an you see here the combination of computer science, the domain science, statistics. Use a software engineering to enable okay domain, okay, see domain science to maximizing the use of data. Actually, it's a combination of statistics and computer science. Okay, work together, and you see how both are clubbed together and come up with the data science. Look at here, only statistics and computer science. Both are okay, clubbed together, and it will come up with the data science. That means we're just analyzing the data and come up with the conclusions or decisions or predictions, whatever it is. That is okay applicable here. It is in computer science viewpoint algorithms, whatever we have discussed. The statistics, mathematics already mentioned. Computer science, whatever I mentioned, AI, ML, deep learning, even generative AI models, explainable AI put together, which is fall under data science. This is what the essence of data science. How come the data science? There are so various aspects under data science. I don't want to go for in depth of the data science. Right. The machine learning already mentioned. See here how that okay it is going to be applicable on the okay layer by layer. According to that specific domain specific, either it's an medical domain, healthcare, or precision, that is agriculture aspect. So it is going to okay identify the particular problem, and already mentioned the life cycle of the deep learning model. The similar kind, predict the problem and that required data set. According to the data set, you have to come up with the conclusion of either are you going to apply machine learning or deep learning. Okay, so these are all the major challenges you are going to um, face during okay that aspect of applying this deep learning models or any okay artificial intelligence techniques on the real time scenario. Mainly the data challenges. Getting the data, even sir, it is freely available, but it is not relevant to our domain. Even you see whatever the Kaggle data sets are just freely available, those benchmark data sets are only applicable for training the models. Okay, exactly. If you would like to come up with your specific models, then you should need an clear-cut data. So the data collection is a big challenge. Even the research perspective, the researcher who is that is plan to solve a particular problem, he or she must have contribute half of the research career on this data collection part itself. Thereafter, learning challenges. What kind of learnings? Okay, that is applicable on this particular aspect. That is important. So the learning challenges, either it's a machine learning alone, it is okay, or deep learning alone is okay. Again, in machine learning, what kind of technique? Either it's an supervised learning is suitable or unsupervised or reinforcement learning. So we have to decide the learning aspects. So learning challenges, then spatio-temporal data. That means spatio means that location based, temporal time based data. Then sparse data, missing, noisy data, various aspects are impacting. Sorry for the making an impact on our research. So we have to be very clear about this sparse, missing, noisy data, so that we need a data pre-processing. I don't know how many of you approached a data mining concept, which is covering all this. Even the feature selections, because again the dimensionality. There are a lot of that is multiple dimensionalities are there in the data. So it is very difficult to manage. So we have to come up with that dimensionality reduction and take part of the data, and we can okay choose the data accordingly. Then multitask learning, already mentioned, that is even it is okay. Doing multitasking, prediction, classification, even grouping, everything is there. So even it is fall under it's a multimodal aspects, which is dealing about multiple data, and it will come up with the multiple results too. These are all the major challenges, mainly on the data collection, learning methodologies, then what kind of data, spatial based or temporal based, that is region based or time based, and then is it the data is sparse data, missing, noisy, everything. I don't want to go for in depth of each and everything, so that only I recommended the participants to refer data mining aspect to come up with what kind of data it is. Okay, so these are the roles of deep learning aspects. See here, deep neural networks, and already we have discussed about this hidden layers and the physical models which we have discussed. And there is a spatial data, whether it is that region based data we can, that means in India, particularly South India, how many patients are get affected during Corona, and how many of them are taken that is for the treatments, and even that corona that is related right vaccines, what kind of vaccines are they taken, everything is going to be spatial data. That is high dimensional, even just dealable. Then multitask learning, see deep neural networks, which is dealing about multi tasking, informs latent futures and everything. I see here how the missing data is going to be filled. Even we'll go for GAN models, that is generative AI, examples, generative adversarial network based, that is generative process to fill those missing values and everything. Even these are the other applications already mentioned, the crop identification, precision agriculture, disease detection. This is what we have discussed under that is health care, image segmentation and clustering, grouping, what kind of image it is, then cloud detection, even that practice, see classification, remote sensing, where that landslide will come, that weather predictions, nutrition deficiency detection from the newborn babies, even that any particular gender, even environment classification, is it that the environment is suitable for agriculture, cultivation, or living, or what kind of environment it is going to be. Like that we can apply these deep learning models and everything to these various fields. That's all about discussion. So, any queries, any clarifications, any clarifications?
Dear participants, if you have any questions, kindly unmute yourself and ask the resource person.
Yeah,
Any
good evening, sir.
good evening.
Yeah, myself, Mr. Lakshmi, sir, from Sasana University. So I'm doing research in IOMT, sir. So
Hmm.
can I explain how the intrusion detection system is affected in IOMT nowadays?
Intrusion detection system, actually, it is one of the major part in the networking aspect. That means
Yes.
um, how, particularly in this domain, medical domain, the fake informations or something that is that molecular aspects or something that may going to get affect the patient's data, or how that fake informations are going to be okay. Get affect your model. For example, that model is well trained. It is capable of detecting the disease in accurate manner. Suppose that model is connected with the internet, how that the intruders or the attackers able to damage the system through their data. So that only okay you have to take care. And is it that informations are true or okay, it's a fake, or from whom you are receiving those informations, you have to be aware of it, and then you can allow. Mostly those kind of devices are not connected internet. Those are dedicatedly it is going to do only that database is going to be upgraded, right? So intrusions are okay not possible, and mainly this kind of domains is what
Okay,
my
sir.
uh,
Yeah, okay, sir.
others. Uh, anything? Any other clarifications?
So, may I have,
Sorry, your voice is not
may I have a
audible.
question, sir? May I?
Yes, yes, we are audible. Yes, proceed.
So may I? So actually, hi, sir. Yes, sir. Sir, actually, I had a quite quick doubt, sir. This is regarding in same what we were discussing in
Sir, your voice is not audible. Can you text
Manikanthan
the
sir,
query?
is it
integration of
possible you
IoT.
can put the query in the chat box also?
Sorry, sir. I got this bad network. Am I audible now?
Yeah,
Ah,
it's
yes.
audible, sir. Audible,
Ah,
sir.
yes.
It's clear.
So actually, sir, so this is maybe I really want to see how how you are thinking, sir, because so I'm working with a bunch of students who have a good knowledge on integrating an IoT with an AI, but so
Hmm.
we currently working in a fields like textile and automobiles. Sir. So what is
Hmm.
happening? We will be having an one model which is an input output which will detect in any quality compliance that will be recorded and that will be trained in a serious time of period, and we are giving an one output of what is getting wrong. So we are using currently using in a textiles and automobiles. So I just want to know, being a mentor, am I guiding a students to right way, because we are just going hackathons, we just applied smart India hackathons and other hackathons. So being an academician, what is your thing of guiding a students in the field of AI, integrating with IoT, applied fields? How you think, sir? So what we really want to focus? Do we have to train the models again and again, or do we use open sources, or what is your methodology you do to take it to the next level of startup? This idea, sir.
Okay. Thank you. Actually, we no need to train the okay our own model. See that this depends upon the problem aspect. see if it's a very confidential problem, size sensitive, then you have to come up with your own model based upon the data, and you can train, and then you take actually whatever I'm narrating as of now, that is, it will take time. But if you are going to use the existing models, you can easily come up with the solutions much quicker way. But the reliability is a question mark. How get that models are trained? So you can choose that model according to the data set and environment. This is what my suggestion, which is machine learning either, or it is a deep learning, whatever it is. You have to aware of that particular problem and its problem nature, and where that is that model is going to resolve that. And accordingly, you can suggest your student to choose, and ask them to act accordingly. That's it.
That is very clear, sir. So, being an like academician, we just have an idea of hackathons, maybe a project. So, any other fields that we really want to try this vertical, sir? So, where we can go and experiment. To so, in perspective of startup. So,
See, there are a lot of that is openings. Openings. So you can apply not only in this textile and that is automobile field, even precision agriculture you can focus, even smart cities, smart transportation, everything, even sustainable energy development, environment, everything. Okay, you can apply. So these are all the hot areas you can focus on the particular domain. Thank you.
thank you so much, sir, for your patient answers.
Thank you.
Good evening, sir. I'm
Good
Dr. B. Shobha, professor from PSN College of Engineering Technology.
Yes, ma'am.
Actually, our students are doing the project related to the diabetic retinopathy, sir.
Okay, madam.
Actually, they developed some basic models, but they are struggling to go to the next level, like as sir asked. So
Madam,
what are your suggestions,
in
sir?
that case, please, you have to tie up with any medical college who is willing to share their data regarding this particular aspect. Then you have to enhance your model and come up with a particular that is device based. That means hardware based device. Definitely, it will be recognizable. So you can tie up with us experts, because as an engineer, we doesn't know about that particular medical aspect. So we have to go
Yes,
for collaboration with doctors and that particular field-based experts to come up with the fine-tuned devices. So you can just do one thing. You can
Dr. Selva Kumar.
collaborate with
Yeah.
that is
Yes,
medical
sir.
people, and come up with the results. That is fine-tuned models, ma'am.
Sir, have you done any work related to that, sir? The diabetic retinopathy? Because
Actually,
you
my
said
PhD scholar already I mentioned during my discuss, that is delivery. My student PhD scholar is currently doing that, but there are a lot of issues we faced during this collaboration and everything. Even we don't have a proper setup to. Even he went to Madurai Medical College, and even here in SRM, CMC, everywhere else we approached. It's a proper procedure to get the data, so that
yes,
we
sir.
are struggled a lot.
Actually, the cost of that real equipment is huge, sir. But if you
Yes.
want to reduce that cost, so we have to go for
Even you can
yes.
come up with IoMT kind of things, madam. Even this is what a final outcome while you are merging IoT with that medical domain. But
Yes.
the thing is, the data and the fine tuning aspects, we don't know about what that up to what level we have to fix that range and everything. So that experts only have to suggest, sir, that getting that recommendation suggestion only is a matter.
Okay, sir. Thank you so much. You have given a very broad view about all the applications, especially towards the point of focus of this particular Atal FTP. Thank you so much, sir.
Thank you, madam. Thank you. Yes, anything?
So
Any other clarification?
only one query in the chat box.
Please, a little bit louder because your voice is low, little bit,
That
closer to the, yes, now it is audible, yes.
நீங்க படிங்க.
Hello.
Is there any security threats while transferring data using IOML?
Yes, sir. Obviously, it is there, sir. Even in that, but in that hospitals, they are not going to share the patient records, isn't it? So we have to be, that is, that patient records are going to be maintained in a confidential way. What disease, okay, that patient has, everything is okay. It is secret. In that case, if, it is, yeah, how they can exchange the data as it is. There are a lot of threats too for attackers. Even our Aadhaar data, even that is the few years ago, that is a couple of years back, I came to know that our Aadhaar database got hacked. If it is going to be get hacked, then you will see, okay, that is, imagine what will happen. So that is definitely we need a security aspect in that case. That's why hospital, that is that the data entry informations are not connected in the internet. That is going to be a separate device, that is the dedicated server which is dealing that particular hospital based information. Nobody is sharing, isn't it? So that is the separate domain. It is dealing everything. Only that that is their that is network alone is going to be accessed. It is not possible. Even single data it will come out of within that network. So there is a threat also is there. So it is not okay. It is distributed form which is kept. It is completely centralized and completely secure. Any other queries? Any other queries? Any other clarifications?
Again, there is a query in the chat box, sir.
Hmm.
Any other data set is available for any syndrome, sir?
Syndrome, actually, my student only gather the data set, sample data. We prepare the data. Once he is going to get complete his research, we are ready to circulate the data in open manner. That means publicly. Till we are not in a position to circulate, because we have to check its stability. Even is it that the data is behaving normally or abnormally? We are testing, under testing. Okay, we are keeping the data. Once it will be okay, stabilized, definitely we are going to circulate in a public domain. It is not available. Sample records are there. You can access. Any other clarifications?
Okay, sir. No queries, sir. So thank you very much for your informative session on the topic precision healthcare through AI and deep learning, sir. Thank you very much, sir.
Thank you. Again, I would like to thank the organizing committee for giving this great opportunity. It's a time is too short, so I'm covering everything in an this a short time span window. Further, any clarifications or any research collaboration, I welcome your collaborations and everything. Thank you for patient listening. Have a happy learnings. Thank you very much.
Thank you very
Recording
much, sir.
stopped.
Thank you. Thank you very much.
Thank you, sir.
Now,
Thank you, sir. Thank you.
thank you very much. Shall I leave the meeting?
Yes, sir. You can leave, sir. Thank you. Dear participants, your next session will be started within 5 minutes. So kindly stay on the meeting. Krishnamurthy sir, welcome you sir.
Krishnamurthy sir?
Yes, sir.
Yes, sir. Good evening, sir.
Good evening, sir.
Yes, sir. We may start within a few minutes, sir. Yeah.
Krishnamurthy sir. Is it audible
Yes,
sir?
Yes, sir.
Sir, shall we start the session sir?
Yes, sir. We can start, sir.
Okay sir, thank you. Pastor, give me an introduction.
Recording in progress.
A very good evening to one and all gathered here. It's my immense pleasure to welcome our resource person, Dr. N. Krishnamurthy sir, Associate Professor, School of Computer Science, Engineering and Information System, VIT Vellore. Welcome you, sir. Before getting into the session, we may see the short intro about our resource person. Dr. N. Krishnamurthy is currently working as Associate Professor, School of Computer Science, Engineering and Information Systems, Vellore Institute of Technology, Vellore. His educational qualifications include his bachelor's degree from Periyar University in the stream of Computer Science and Engineering in 2002, and completed his master's degree from Anna University in the stream of Computer Science and Engineering at 2008. He completed his doctoral from Anna University in the year of 2015. He is serving more than 23 years of experiences in both teaching as well as industry projects. He worked on various projects and completed more than 13 consultancy projects. He published 2 books and published more than 85 journals and conference papers. He also filed a patent in the topic of development of solar-powered insecticide sprayer. He organized more than 10 national level seminars and workshops and also received various funds from funding agencies like DRDO, Board of Research in Nuclear Science, Ministry of Earth Science, Department of Biotechnology, National Board for High Mathematics. He also received a project fund from various agencies like AICT RP scheme and ICSSR. He received awards like Best Faculty Award, Appreciation Award for the Research and Development, Special Award for the Active Researcher, and also got Outstanding Engineer Award from International Institute of Organized Research. He acted as an invited talks and resource person for national level seminars and workshops in the various topics like funding agencies for research, big data management and cloud computing analytics, green computing, problem solving and Python programming, and in various areas. He is also a lifetime member of Computer Science Institute of India. With this grace, I just like to hand over the session to our resource person, Dr. N. Krishnamurthy, sir. Please, sir.
Very good evening to one and all present here. Whether my voice is audible?
Yes, sir, it's audible.
Whether I have
Yeah. Yes, sir, it's visible.
I shall introduce myself as the introduction given by the other Department of Computer Application. I had been thanked this the principal Dr. Asogan sir and giving me an opportunity to share my insights into this artificial. So I'll be taking you in concept overview of this is my outline presentation which goes on such a flow like okay. So the main agenda which I'm on first one is disruptive technology. Why we are moving information disruptive technology. And after that, we'll be moving on to this the topic which was like overview of. I have gone through the earlier session also. Some of the people are talking about artificial. A little bit. I'm not going in depth of what the algorithms or the models are, but I'll be giving you a general overview because some participants background. So I'll be giving a general overview of what. That was my second agenda in that. After that, we'll be moving on to this automation. Why we are moving for an automation. In that, we'll be ending with robotic process. How robots are helpful in surgery and taking. And after that, the next topic which we go is remote patient. In that, I'll be separately, exclusively concentrating CGM. That is nothing but continuous glucose monitor. And the last comes to the data analytics parts, like starting from descriptive analytics, predictive analytics, descriptive analytics. They are going for this. How these analytics are helpful in accurate diagnostic for your and these are some guidelines which topics which is relevant to this the topic which has been given to. Apart from that, I'll be taking some important every people follow this. The last is my agenda of my flow of okay. My before we enter into this first concept is disruptive technology. Any other people have heard about what is disruptive technology? If no problem, I'll be sharing this. Have heard about what is information technology? That's a field where the number of people work in the called as information. But we are moving from this slightly from IT to ET. Okay, IT stands for disruptive technology. Before we enter that, first disruptive technology, I want to know there is a concept called as necessity. Like anything new devices to be invented, which there is a necessity. Unless there is a necessity, new device or new equipment. Okay? This proverb has been given by this Greek philosopher as called Plato. Until there is a necessity, we are not. Is a real creator. Until there is a need, we'll be creating something. it was evolved from his idea. As we say, it is necessity is the mother of invention. Then we can call who is the father. Okay, create that necessity to fulfill a solution to this. We have some resourcefulness. What the resource create or invent that device or something. Once you have the resources, the necessity creating something, the desire in each and every person's will make you to achieve your goal. Until there is no desire, you cannot do that. If there is a necessity, have the resources, and you cannot create until there is no desire with you. Okay? As you are going to create or invent something, a solution to our problems makes our life very easy. The diagrammatic representation gives you has given this necessity is the mother of invention. So now we'll move on to this. What is IT? How we are moving to that? What is IT? IT stands information technology. You have some softwares or models to try to manage that models or maintaining. You will be maintaining the software. That is nothing but we call this information technology. But slightly we are leveraging from IT information technology to disruptive technology. What is disruptive technology means? You will have a product, but that product will be reshaping or rechanging with new idea or creativity or innovation to have a new product. But sometimes the old existing technology may be displaced, new technology comes to the market with lower cost, or sometimes the low old technology also will be trying to continue this journey with a new one. This is called as disruptive technology. What is a traditional IT focuses? It is going to maintain the system, or it's going to increase the efficiency, or how it operates. Like that's is mainly focused on technology. What is DT stands for? That's will be changing. Some technologies which comes around disruptive or artificial OT, robotics, cybersecurity, quantum computing, it comes on. To understand what is disruptive technology, I'll be starting with an example. Okay, can you see this slide? There is a diagrammatic representation shows that in a junction or a railway station, we have some peoples. Okay, these people, so that they are called as porters. Okay, they used to carry the luggages. From a person comes from some long way distance, they used to carry this luggages, and after carrying this, they'll used to get some as their honorarium or something to the work which they have done. But as this is the existing technology, I'm saying what is to say an example of what is the existing, which was earlier period which we used to do. But now it is changing the existing technology shape with some creative or innovative idea to have a new product. Okay, and sometimes the new product will come to the market with lower cost, and one will be there, and otherwise sometimes the old technology based, or sometimes old technology also may be trying to continue with the same. Okay, here as the person is going to carry his luggages, there is a bag. In that bag, a creative innovative idea has been added into this bag. Okay, that was inventing a new wheel. Okay, 4 wheels and a handle to to troll this bag. Okay, as this invention of this wheel in this bag added to this bag, this porter's job has been changed by this. As in, even though porter's job has been gone out, but there is a manufacturing of this bag with trolley bag with the hand symbol and this was the what this you can understand what is this disruptive technology. The old technology is going to reshape or change with the new creativity. What's the creativity or innovative idea here is there was a wheel added to this bag and a handle to, to take care anywhere of your wherever you go. This is an example to say what is disruptive technology. We can come to this what is disruptive technology. Then innovation. You are going to create some innovation in the existing technology. Nowadays, AI is also one of your disruptive technology because in every business or whatever the fields, AI is going to change that what the existing to a new one. Okay? I'll say some with different examples for disruptive. The innovation you're going to have to the existing technologies, which may be often displace the established products, may be often displacing or if the established products also maybe trying to continue, okay, with new markets. Like we see, this AI is a disruptive technology because it significantly alters how industries, sometimes it changes the business or the way the consumers who consume it. Okay, see, in that same example, the consumer was used to have this service from this portals, but now they are not using its consumers. Operation is going to change, behavior is going to change. Instead of looking the service from this portal, they are going to have their own wheel assisted bags they are going to use. So it's consumers operate by introducing new capabilities, and AI transforms different sectors like healthcare, but your title of your FDP is also on healthcare, logistics. Yeah. So this is what is disruptive technology. Some characteristics of your disruptive technology is radical change. Have a dramatical change from the existing. Like you will have reshape the existing and change this. That shape of this bag is changed by adding a wheel and displaced established technology. Like the porter job has been reframed in a different way. Okay, like it changes the behavior of the consumer also on a regular basis. Rapid advancement, like as we are introducing new technologies like artificial integrated of internet of things, like which creating is something entirely new. Okay, uh, these are the these are the different key characteristics. It have a radical change, changes the behavior. Rapid advancement does not eliminate completely, like you'll have the new one to new technologies to displace the existing to have a new technology. There are 4 stages in your description. Initially you want to point out what where you can use your innovation or creative. Okay? Normally an interview in IT industry also focus on the students, like they how they are going. Normally, because if they go for a panel and they the same setup every student, like normal 1+1, what is that? They'll say, but in such a way, how we are treating it as two, how we are proving it as two in a different creative or innovative idea, which makes you to have best impression. That if you're having some new point of view to the product, that makes your disruption. Okay, and after that, you evaluate the product to change different, like how we have added the wheel, and you converge that to have a reimagination, and the new existing technology will be replaced by the new one. There are the different stages of disruption. This disruptive technology is going to be in different fields. There's some examples wherever you is in AI. AI is also one of a disruptive technology. It's going to be in genomics, like gene prediction, all those several places where you are going to use technology. This is the one example which I have already illustrated how this disruptive technology example of this. We'll see a little bit some more examples. So this is the example which you see that earlier we used grind with by using objects. Here you see this in this left side, the ladies is going to be a dynamical nature, and this objects will be statical nature. We are trying to introduce a different manner that as we are inventing the grinders. Here, what is that? The person who operates this grinder is going to be static. The grinder is going to be in a dynamic. Entirely, you are changing new idea, innovative idea. Okay. Ultimately, it is going to be in vice versa. Like this, they are going to be in your dynamic portion. They have some physical activity there. But see here, you do not have a physical activity person who operates these products. The physical activity is going to be dynamic of this products. An example of what is disruptive technology. Still some more example we see this. We have seen with grinder. This, like you have these objects I have nowadays. It is displaced or no, none of your families are not used of stone based objects, but they're going to have in the form of grinder based mixer. Okay. Some of the peoples now will be not been the aware of these ideas. Earlier periods we called this a floppy disk, which is storage device which comes in 3.4 inches and 8 inches. Nowadays you do not have floppy disk for a storage, but now this is going to be reshaped or changed by a creative or innovative idea to have your pen drives, storage. Let's call this a tertiary storage. You have primary storage, second, your tertiary storage, your pen drives, and all comes tertiary storage. So this is an example of another disruptive technology. Now this post has been removed from this post office system. Not have a box of carrying it, but this technology is reaching this email, electronic mail. Uh, Even though email now system a platform, WhatsApp, group communication, all those. Initially used to write a letter, have a from address and to address will be stamp and paper stamp on this sending communication to one person. Now it is has changed. It takes time, but nowadays it's very easy. After sending it within a fraction of seconds, receiver can receive the some examples like see this I said no in earlier period you have separate device taking a photographs of camera, you have a calculator to do some calculations, and to see your time have a clock, you have a separate hand written notebooks to have your personal or to have your phone numbers or something. Now this is each and every devices for a single purpose, but we specific purpose. It is used for only a photograph, it is for calculation, it is used to note what is the timing, what's the time now, used to have some personal information. Now all it is going to be integrated with device. Either we say it is a smartphones because smartphones, all those devices to all in one. Okay, so we say it is multi-purpose. Here it is a generic. Here it is specific. Here it is generic. General purpose. Every purpose can be stated. This is an example of disruptive technology. And some more examples. Like earlier period, we have a blackboards. We have copies to talk to write from there. Normally, you see this is an education system. You start to write from top to bottom. As you started to write from top to bottom in your blackboard or a paper, but our life goes from bottom to top. Normally we used to read your books from top to bottom. Our life also goes from bottom to top, like that's a, like we say, but nowadays technology is changing to a smart board. Instead of having your a chalk, you have your pens to write, easy way of giving a presentation. Nowadays this a research survey says also that when people spend time in taking a textbook and reading the contents, they read with their imagination. And normally this person, even your students, they are not used to spend their time to take a textbook. They have all your materials in the form of they used to find any solutions or assignments ChatGPT. So this is also one of a disruptive technology. Books going to be get the doubts clarification by giving a prompts, so that it's a prompt engineer will give you a different prompts by giving a query to your to giving a query in their ChatGPT or its Gemini or something. This is the first part. What is disruptive technology? Here, artificial. I'm saying artificial. Here, we'll move on to the second part. So, as we are moving from this is the cartoon picture says that earlier system was a huge computer system occupies a room or entire building or something. Now it has been changed. As a disruptive technology, we are having innovation. The miniature, it occupies the less space. As the system's size is going to be reduced, it says in a form of a funny manner. Let's see this: the persons who operate these machines earlier was to be a fit one. They have a physical activity. Now we have an automation, and the devices are becoming miniature and thin size. But the people who operate this, they are becoming an obese, increasing in the size because they do not have a physical. Everything's automation. They are becoming as an obesity. So this first part of my agenda is this technology. We'll move on to the second. The topic which I have been given with I have seen. I think this the concept being repeated the earlier present bear with me. I'll be giving a general overview of what is artificial, what is machine, what is deep, how the present, how it is helpful for. That's an overview which you know what is artificial intelligence. Sometimes I ask my students whether this the system operate in one. Normally, this is not an apart from goes only goes in one. are slave machines who operate this machine because natural intelligence by our God to us, brain which but most genius people utilize brain capacity 10%. Guys,